Data analysis in Python. This is a continuation really only from our beginning Python course. We've tried to keep the requirements for this data analysis course as minimal as possible to make it useful to as wide a range of people at the university as possible. We don't want people to feel they have to be an expert in Python before they can start using it for making their job and life easier. So we only require a relatively small amount of Python experience. But that said, there might be some things in this course which are new to you. So as we're going through, do feel free to ask in the chat if there's a particular piece of syntax or particular function that we're using that you're not sure how it works. Please do post a message and ask for a bit of clarification, and we'll try and help out. In order to run the session today, in the previous classes, we've been using Jupyter Lab, which we've installed through Anaconda. Jupyter Lab, we've been writing text files with our Python scripts in, and then running them in a terminal. In the session today, we're going to be using a tool called a Jupyter Notebook. Now, it's possible some of you have used a Jupyter Notebook before, so just to get a bit of a sense of the room, could people post in the chat whether they have or have never used a Jupyter Notebook before? No, good. So lots of people who haven't used them before, so that's going to be the first thing we go through today. Those who have used it before, this first 10-15 minutes or so, feel free to follow through it as well. Otherwise, since all the material is self-guided, you can just carry on through to the next section without waiting for me to get to it, if you so wish. So the first thing to make sure you've all got is Anaconda Navigator, all started up and running. So I'm just going to give you all a minute or so, or 30 seconds or so, to start that up and have it running in the background before I carry on to actually starting the session. Okay, so hopefully you will have Anaconda Navigator started up now and running. It should look something like what I see on my screen here. You might have a slightly different list of apps, or you might have slightly different versions of things, but hopefully it's a similar kind of idea. Now, I said we were going to be using Jupyter Notebooks today. However, I don't want you to immediately click on the Jupyter Notebook launch button. If you do want to use that mode of launching Jupyter Notebooks, it's okay. It's going to work just fine. And if you feel more comfortable there, that's okay. But for the session today, we are going to use Jupyter Lab as the way to start the Jupyter Notebook server. I'm going to explain what these terms mean in a little bit. But if you go ahead on the Jupyter Lab tile, which is probably the first one, and click on the launch button, that should open up in your web browser, one that I prepared earlier, that looks something like this. So I'll just move those to the side so we can see both of them. So click on the Jupyter Lab launch, and that'll open up in your web browser something that looks like this. I'm going to go ahead and make this window here full screen and extra full screen, and the rest of the session we're going to be living inside this window here. So Jupyter Lab is a web-based, I say web-based, it runs entirely on your local computer, but it works in your web browser, even though it's entirely local. And it gives you an environment where you can run Python code, you can write Python code. One of the things it has built into it is its own Jupyter Notebook environment. So the very top icon you should see on your launcher, and if you've been to our previous sessions, you might not be seeing the same view. So just go ahead and you might, for example, have something that looks like this. Just go ahead and close all the tabs at the top. That's perfectly fine. Click on the Python 3 icon under the notebook header, and that will open up a Jupyter Notebook which should fill the whole screen. So having clicked on that Jupyter Notebook Python 3 tile, you should get something that looks something like this. Now this is called a Jupyter Notebook. I'll just give you 30 seconds or 20 seconds or so to get this started up. And again, if any issues, post in the chat. What we have here is a Jupyter Notebook. A Jupyter Notebook is a way of writing and running Python code in an interactive way. And it also provides us with a bunch of extra features which are really useful when we're doing data analysis kinds of tasks. So at the first case, what we can do is we click inside the grey area here and we can type any Python code we like. I'm going to keep it nice and simple. We can print hello. Now, if you just press enter at the end of the line, it just puts another line inside that cell. So it doesn't run the code just by pressing enter. If you want to run this cell, you either click on the plus button just above it up there, or hold down Shift and press enter. I'll click the play button this time, but in the course of this session, I'll probably quite regularly be using Shift enter or Control enter to run the cells. So you will sometimes see me running a cell without clicking it, and that's what's happening there. If I click the play button, it runs that cell and prints hello. It also gives every cell that's been run a number, so you can keep track of which order they've been run in, because in principle it's possible to rerun cells that are further up the page after having run further cells that are further down the page. It can get confusing, and we'll try and cover that later. So I'm just going to switch over to the notes now and copy and paste a few examples from here. So one thing we can do, as I said before, is have code over multiple lines. I'll just show that by typing. So A equals 5, B equals 7, A plus B. If I do Shift Enter, it runs that cell and displays 12 on the screen. Notice here in this second case, I haven't had to write print A plus B. I didn't need to do this, because the way that Jupyter Notebooks work is whatever the last thing in a cell is will be displayed onto the screen. So here, because A and B has the value 12, it's displayed 12 underneath the cell as the output for that cell. And you see the output and the input have got corresponding numbers. As well as being able to run Python code as we have done in the script so far, it also gives us an extra ability to, didn't mean to make that small, there we go. An extra ability to display output from commands in a slightly more visually pleasing way. Now, don't worry about what this bit of code here does. We're going to be discovering how these things work throughout the session today. I'm just going to make my font a bit bigger. We're going to be discovering how this works throughout the session today. But if you run this, it's going to print something that looks like a nicely presented table of numbers, where you hover over it and the lines get highlighted, which is useful when you have larger tables of data. The thing that's really useful, however, is the ability to display plots. So here, again, I'm just copying and pasting this in. We'll be discovering how these things work throughout the course. If I run this cell with Shift Enter, we get a plot coming up in line. So if you use something like Mathematica, or I think MATLAB can do this, and R notebooks do this too, it lets you run code and get the output from that code right there, and then you can carry on further underneath and, print whatever you want, and you've got the code in line at the point where you ask the figure to be shown. The final thing that it allows you to do is, as well as having cells which contain code, at the top of the window there's a drop-down menu that says code at the moment, and with this cell selected, if I change that to say Markdown, if I click on the Markdown button on the drop-down menu, you see the square brackets at the beginning have disappeared, and now this won't accept Python code and run the Python code. It will instead accept Markdown. Now, Markdown is a way of applying formatting and design to plain text. So you can start headers by doing a hash key, and you can write header. And then if we run that cell, you see it turns the word header into a big word header. You can then double click on it to edit it. You can write bold text and italics, or I could if I could spell correctly. And you see it formats it with bold and italics. And so what this allows you to do is to interlace with your code blocks of text which describe what your code is doing. And the real powerful thing about this is it gives you the ability to write a whole report with introduction sections, bits explaining your science or whatever it is that you're doing, intersperse that with the code which is executing your analysis, and take that whole report and compile it to something like a PDF and allow you to give that out to people as, this is all the stuff I did and the code's all in there as well. On top of that, it also allows you to give the notebook to other people so that they can take this report you've written and they can run it themselves and see if they can reproduce your outputs. A particularly famous example of this, though it's becoming more and more common these days, was the LIGO collaboration, when they were looking for gravitational waves, published all of their results as Jupyter Notebooks, with the data provided alongside them, so that people around the world, citizen scientists, could download these files and run the same analysis that was performed by the people at the LIGO collaboration and see if they could reproduce the science, have a go at tweaking the numbers, playing around with things, and see if they could discover anything in there as well. So it's a really good way of getting engagement with people outside of your local small field and giving them the ability to play around with the code there and then. So there was a question in there that's now looking fine. So yes, there's a question there about the plot not showing up. There's two things. Firstly, it sometimes takes a few seconds for the plot to appear because it's running the code. Secondly, you sometimes have to run the cell twice for a plot to appear. That's supposed to be what this magic little line at the top means, that you don't have to run it more than once. But if your plot doesn't show up, just run that cell again and it should then show up. So to give you all a chance to have a little play around with Jupyter Notebooks, I'm going to scroll down to the bottom of that first page in the documentation. And there's an exercise there, which contains a block of code. So what I'd like you to do, just for a minute or two to get a handle on this stuff, is to copy that code into a few cells in your notebook. And I'll just switch back to the notebook a second. You can add new cells if you click in a cell by clicking the plus button at the top. You can add as many cells as you like by pressing that button there. So I want you to take this block of code, split it over multiple cells, and in between some of those cells, add a little markdown block, which describes just in a few words as a comment what the next little line of code does. I'm going to be going through that on the screen myself just to give you an idea of what that demonstration looks like, and I'll just give you a few minutes to have a play with that yourself. Kunal asks, is there a shortcut for adding cells? Yes, there is. So when you've got a cell selected and the cursor is flashing inside there, if you press escape, you'll see that the cursor has disappeared and it's no longer flashing inside the cell, but the cell is still selected. In this mode here, if you press the A key on your keyboard like this, it puts another cell below where you are. And if you want to add a cell above where you are, you can press the B key on the keyboard, I think. Yes, press the B key and that will add a cell above where you are. How can I go back and rerun? So if you want to, well, you can move up and down with the arrow keys. If you want to rerun all of the cells from the start, if you go to the kernel button at the top, and there is a restart kernel and run all cells button, and that will get everything rerunning from the beginning. So yeah, just take a minute or so now, just have a play with that example, and I'll do the same in my window here. And again, any questions, please do post in the chat, and one of us will be there to help you. Olivia asking, how did I add the text bit? If anyone's happy carrying on, just carry on for the minute while I answer some questions. So, Olivia, if you select a cell so you've got it blue like this, at the top here there's a drop-down menu. By default, code is selected because that's the default cell type. Change that to markdown. And one thing you'll see happen is that the square brackets in front of it disappear. So that's how you know you're in markdown mode and not in code mode. Click inside the cell, and there you can type something like header. So a hash and a space at the beginning of the line makes it a header. 2 stars makes bold, and an underscore makes italic. And if you use the back tick key on your keyboard, which everyone's keyboard's different, but in mine it's in the top left, you can write code block like that. And I'm just going to copy that into another cell so that we've got the example and the real one. So this code here generates something that looks like this underneath. Does that answer your question, Olivia? Great. And Rob, your cells aren't showing the answers after running. So if you could post in the chat there what you've typed into your cell, and then I'll see if I can reproduce it on the screen. Okay, I'll come to you in a second. So the first 2 things in the exercise, if I copy those 2 lines there, for example, and I type that into a code cell, if I run that cell there, you're saying you don't see any output. And that's correct, you don't see any output, because in this case here, the last line of code, and I say line in inverted commas, I know you can't see me, but I am, the last line of code in that cell doesn't have a value because it's assigning it to a variable, and the act of assigning something to a variable in Python kind of soaks up the value that you would have been passing in. And so this line of code here doesn't have an output of any kind, it's just performing a side effect. And so you don't get any output from here. If we put in this cell my purchases, and then purchase, there we go, and run that, there we do get an output because that line has a value. And Kunal, how would I tell Jupyter to run several cells together? So, I don't know, let's try something. If I select two cells at once, which I can do by clicking on one, holding down Shift and clicking on another. If I press play, it looks like they both run. So you can select a cell, select another cell with Shift Enter or Control Enter I think works, and then press the play button and both of them should run. However, the easiest way to get that to work is to go to kernel at the top, restart kernel and run all cells, and that will run everything. Okay, so question here about the other things in this drop-down menu. So you see one that says raw. That basically, in the mode where you want to generate a PDF, Jupyter won't do anything to the cell before just putting it in the PDF. So it's just really, really basic and raw. So you never need to use that one. Heading, I don't know what that one does. I'm guessing it's just a shortcut for a markdown cell. The only two cell types I ever use is code and markdown. That's all I've ever needed. Okay, so hopefully you've all had a chance to have a little play around with the notebook. It does take some getting used to. I do strongly recommend getting used to using some of the keyboard shortcuts. So it's going to make your life a lot easier if you keep your hands on the keyboard rather than moving around. So for example, I'm in this cell here. I can press Escape to deselect the cursor, press up on the keyboard, and then press Enter, and then now I'm typing into the cell above. If I press Escape there and press B, I'm now in the cell below. I can press Enter and then type A equals 7, for example. I can run that with Shift Enter, and then I can move down to the bottom cell here and then run that cell again, for example. I've done all of that without touching the mouse at all, and that's going to make your life easier as you become more accustomed to using Jupyter Notebooks. Okay, so moving on to the next section here. First thing we're going to do is in the notes, at the bottom of every page there's a next button. Go ahead and click on that next button now. And in general, Christopher will probably be posting into the chat the link to the current page we're on. But in general, you should be able to just follow through in the order I'm going. I think Christopher might be helping someone with a question at the moment. So, introduction to Pandas. So this course is about data analysis in Python because it's a very, very common thing that people in all walks of the university have some kind of data they want to analyze. Maybe it's in a spreadsheet, maybe it's in a text file, maybe it's downloading from a website. Often what they want to do is ask a few questions about it, for example, to select a subset of the data or to merge it with another form of data, and often to plot a graph at the end. A lot of science comes down to a bit of analysis and plotting a graph, as I'm sure you're all aware. So the idea of this course was to get people to the point where they can do that set of tasks without having to do sort of too much complicated things. We want to kind of find a critical path to getting the solution done. So in Pandas, the primary tool that provides these features that you need to do those things is a tool called Pandas. Now Pandas is a third-party module. It's not core Python. It's written by people around the world writing stuff in their own free time, written by people like you and me. But it's included by default in Anaconda, which is one of the reasons we use it. But the reason it's included by default in Anaconda is because it's by far one of the most popular Python packages out there. It provides a couple of basic pieces of functionality. The first of which is a series, which is what we're going to be covering first. And the second is a data frame, which we'll come on to in a little bit. But to get a little sense from people in the room, could you let me know if you've ever used Pandas before? Or if you've ever done anything with Pandas or just had to work on code which has used Pandas before? So we're seeing a few people with yes, a few people with no. Okay, good. So lots of people have never used it before. You're the perfect target audience. However, those who have used it before, hopefully will go through some things which will clarify stuff, explain how stuff works underneath. And again, if there's anything that you're really comfortable with, feel free to move through a little bit faster or ask questions about how you can do other things about it in the chat. Yeah, so a few people have used it. Most people haven't. Wonderful. As I said, Pandas provides a few different tools. The first of which is the series. Now, a series in Python, in Pandas, sorry, you can access by importing it from the Pandas module. So I'm going to start a new notebook, and I'm going to do that by clicking on the plus button up in the top left where it says New Launcher. And I'm going to select a Jupyter Python 3 notebook. I'm going to save and close the old one because we don't need that one anymore. And I'm also going to rename the notebook by right-clicking on the tab at the top, select Rename Notebook, and I'm going to call this Pandas. Giving your notebooks a sensible name is a good idea because just having everything called Untitled 1 and 2 and 3 isn't going to make your life very easy. So we start off by from Pandas import series. So from the Pandas module, we're importing the class series. I run that with Shift Enter, think about it for a moment, and we've got access to a series. I'm going to copy this line of that list because otherwise I'll get a different set of numbers to you. So the way that you create a series in Pandas is by calling the series class like a function, and you can provide any list of data to the series object because at its core the series is kind of like a Python list. It works in a very similar way superficially, and we're going to be investigating some of the differences shortly. So the easiest way to make a series is to give it a list of numbers. So here inside the round brackets, I've given it a list of numbers with the square brackets. These are all integers in this situation. If I run that cell, it's going to, because I haven't assigned it to a variable, it's going to display the value of that object. And this is a view we're going to have to get very used to seeing. We're going to be seeing a lot of series, or whatever the plural is. So I'm going to explain now what the things on this screen mean and what we should be paying attention to when we see them. Now, the first thing you hopefully notice is that this line of numbers on the right-hand side are the same numbers and in the same order than those we passed in the list at the top. 14, 7, 3, minus 7, and 8. So the first thing to notice is that series has maintained the order that we pass things in, and that makes sense because you'd hope that a series is serial and maintains ordering. The next thing to look at is on the left-hand side, we have the numbers 0, 1, 2, 3, 4. These are the index. You can think of these as being the row number or the row label, because we'll see in a while that the row label can be strings as well as being integers. Because we haven't told it what labels we want to apply, it's automatically generated the numbers starting from 0. Because remember that Python always starts counting from 0. The final thing to be aware of is the D type. D type means data type. In this case, it is an int 64. Int means integer. 64 means it's a 64-bit integer. 64-bit integers can get very large. They can get as large as 2 to the power of 64. So the largest integer you can have inside this thing is pretty much that big. Except actually it's only that big because it goes positive and negative. So you can hold very, very large numbers inside here by default. The reason that it tells us what the type is here is because Pandas is going to use the type of the data to perform certain optimizations as it does stuff, which is useful when we're dealing with millions of numbers and we want to do mathematical things to them. It's going to do it nice and fast. As I said, here we didn't specify an index, so it generated one for us. We can go ahead and give an index to it. Index equals, so as a second argument to series, we pass a list of, well, whatever you want. But here I'm going to use a couple of strings, single character strings, but strings nonetheless. And when we run that, we see printed out on the screen the same numbers as before, but here we have a set of indices. Just take 30 seconds or so now just to have a go at making sure you can import pandas, you can generate these series, and I'll be back in a moment to carry on to the next section. Okay, got a question there in the chat from Dan. Is it impossible to index from a sliced range? Okay, so you're asking, for example, if you wanted to do something like, you wanted to have the numbers, sorry, something like 1 to 6 in there. That's fake syntax, that won't work. So if you wanted to do something like that, you should be able to use the range syntax and do 5, 10, and that will give us, nope, am I missing a bracket? Oh, because it's a comma, not a colon. There we go. So in the index there, I passed in the range function, and so it started from 5 and gone through to 1 less than 10. Is that what you meant, Dan? Great. And Adam, is there a shorthand for copying a previous line? Yes, there is. So if you've got a cell selected, you press escape so that your cursor's not in there. I think if you press Y and then P, Y and then P. Nope, someone said there's a help if you need it. Edit. Copy is C, paste is V. Okay, so you select it, you press C, and then you press V. There we go. So C to copy, just pressing the C key by itself, and then V to paste. And you can delete a cell with pressing D twice. I'm not expecting you to remember all of these. There is a way to get the keyboard shortcuts, but I can't remember how you do it. It's probably in there somewhere. If anyone can see how to get the Jupyter Notebook help up, then that would be great. Okay. So let's go ahead and actually do something with these things. So I'm going to go back to, actually which one, I'm going to try and keep up with what I've got in the notes. I'm going to go back to this cell here. So I'm going to delete these other cells. So we have here a series. I'm going to assign that to a variable s because I'm unimaginative. And see, this time, because we've assigned it to a variable, it hasn't printed anything out. But we can have a look by writing s, and then it shows up on the screen. Escape and B to do another cell, or press the plus button there. So we want to ask something of it. I said that series are like lists, and they are like lists in many ways. One of which is that you can use square brackets to select items out of them. And in this way, they're actually starting to act a little bit more like dictionaries, because we don't put a number in here per se, although you can if your indices are number. You put in here the row label that you want to select. So in this case here, because we labeled them A, B, C, D, and E as strings, we can pass in here C. We run that, and it gives us back C is the third item, C is the third item, so C gives us what happens to be number 3. If we do it with A, we get 14. So it gives us back the value from the list, from the series, sorry. If you're used to R and their pandas, their data frames and so on, they would give you back a list with one item in, which is 14. However, pandas just gives you back the number itself. So it's saying that the value from this list associated with the value A is 14. We're going to see later on some more advanced things that you can put inside these square brackets. But if you just put a single item by itself, it's going to look up that row, find the index label that matches it, and return it back to you. You can also edit in the same way. So we can do S and we can edit, let's edit E, and we can set the value to be something else. So we can say this should be minus 999. Run that, it's done it. New cell S, and we see that E has been updated and changed. So there's 3 exercises after this bit here. Don't necessarily worry about doing all of them. In general, there's a few more exercises than you really need. They're just there to stretch you if you're interested. Just take a minute or two to have a go at those, and then I'll move on to the next bit. Right, it's a question there from Adam in the chat. So comparing to MATLAB, this is basically a way of storing data, but can we add in strings as well? You absolutely can. So in the examples here, I've been having integers as my types here. If I take my series example and make a bit of space and do it here, you can absolutely put this is a word, and actually just run it without the S at the beginning. And you see we've got some data here, which is, this is a word. So you can put any kind of data in here at all. You'll notice this time the D type has changed to object. That's its sort of generic, I don't know anything more than it's some kind of object. That means that you're losing the ability to have efficiency and speed when you're dealing with these things. So if you wanted to do mathematical operations to this series, it would become slower than it would be if they were all integers, for example. In general, it's a good idea for each series to have one kind of data, so have these all as strings or all as integers or all as floats, but it is possible to mix them together. Now, suddenly my shortcuts stopped working, so if your shortcuts won't work if your cursor is flashing there, so if you want to, for example, copy or do a cell underneath, make sure you pressed escape so that the blue outline around the cell disappears and it's just grey and there's no flashing cursor there anymore. That means that when you do something like A to do a cell above, it works correctly. So give that a go and see if that helps. And I'll delete that cell. So from those exercises we've just been going through there, there's a question there about how does a Pandas series differ from a list or dictionary? And while these ones above are just having a play around and having a go with these things yourself, yeah, I answered this question about how a series differs from a dictionary and a list. I wanted to point these out because it's useful to have an understanding. Because one of the things you need to get used to in programming is choosing the right kind of container for the data you're dealing with. And so knowing how they compare against each other is a useful first step along that. So they're like dictionaries because you can just access by any kind of key. But importantly, series are ordered where dictionaries aren't. We'll see later on that series can have repeated indices. So while you can't have a dictionary with the same key repeated, you can have that in a series. It's generally not a good idea, but sometimes it does make sense, so be aware of that. And series are sped up and made fast by using NumPy or NumPy behind the scenes. A list, again, they're in order, and you can index by integer in principle, but a series lets you access stuff by key, as we saw, and again, it's made faster. So on the whole, it takes the best bits from both and makes it faster, but there are some situations where you don't want something quite as difficult to interact with as a series. It's not built into Python, for example. So, series operations. Let's have a look at an example, and I'm going to be asking for some audience participation in a moment. So here we have a list. If we wanted to double all of the items inside that list, let's do something like my list times 2. Now, could you post in the chat there and let me know what's going to happen when I do the list multiplied by 2? Is it going to double all of the numbers? And you can cheat by trying it yourself. Yeah, okay, good. Lots of people saying yes. Let's see what happens. Oh, that's weird, isn't it? So because this is a built-in Python list and not a series, it isn't making the assumption about it being numerical data. A Python list is just designed as a container for information. So what it's actually done is it's taken our list, 368,410, and it has doubled it. And it's doubled it in the most literally minded way you can imagine. It has just repeated itself again. If we wanted to double every item in the list, we'd have to manually loop over it, put the doubled items into a new list, and that takes some time. And takes some lines of code as well. With only 5 items, you're not really going to notice any slowdown. But if you have 1 million items, putting it in a Python list and looping over it is going to be slow. So let's take this same list and let's make a series called S. In fact, let's call it S1. Let's have this different name from before. And so we're taking our list, we are converting it into a series and giving it a name. S1 now looks like this. So it's those same numbers, but it's a Pandas series. If we multiply that by 2, it's done the correct thing. So it hasn't duplicated the list, it has applied this operation to each item in the list. And because it knows that they are integers, it is able to do this in a very, very fast and efficient way. Right, so the code will go green. Yeah, so while it's running, it goes green apparently. So that's the difference between the two, David. So this allows you to run this numerical operation on everything inside this list. Now, this is useful if you've got numbers inside there and you want to be able to double them or find averages or things like this. But as well as doing numerical operations like times 2, or we could do minus 2, that works too. So 3 has become 1, 6 has become 4, etc. We can also do Boolean operations, so logical questions about our data. So instead of doing a mathematical operation which changes the numbers, we can ask questions which are going to give us back true or false answers. So for example, we can say, is S1, I'm going to change this cell here just to be S1, so we've got a reference, is S1 greater than 6? And we run that, and it gives us back the answer, but it's giving us back the answer for every single row. It might look like we're asking the question of, is this whole series bigger than 6? But actually what this ends up meaning, I'll just scroll down a little bit, what this ends up meaning is for each item in the list, ask each of them, are they greater than 6? So 3 is not greater than 6, 6 is not greater than 6, 8 is, 4 isn't, 10 is. And so it gives us back this list of trues and falses. There's a question there from Olivia. So this means in lists I can only do these kinds of operations through looping. Realistically, yes, there are ways to make it look like you're not looping, but you are always looping. So what this has given us here is ability to ask these questions and get back trues and falses. You see that the D type has changed to bool for Boolean. We'll see in a moment how we can actually use these ourselves, but have a quick go now, just have a play with the series, try doing multiplications on them and try doing greater thans, try less thans, or equals tos and things like this, and see what works and see if you can get stuff to give you output that you expect. And I'll be back in a few minutes to move on to the next bit. Jeanne's asking, how do you get just the numbers from the series? So you want to get not all of the stuff around it, you just want to get the values, and you can get that by writing dot values. And that gives you back the array with just the values out of there. Okay, great. So a few good conversations happening in the chat there. So Bo's asking, is NumPy faster than Pandas or not? So Pandas, as Christopher says, uses NumPy behind the scenes. Everything underlying it is NumPy, and it's just using Pandas as a way of giving a nice interface on top. Yeah, as Christopher says, always one step ahead of me is he. I'm going to go, again, I'm going to just make some more space underneath, and I'm going to come back to our S thing from before. I'm going to change S so that the last item in it, actually no, I'm going to redefine it so that it's the example from before. There we go. So, S, A, B, C, D, E, and the numbers. I showed you before that with an S you can do something, oh dear, you can do something like S is greater than, let's say greater than 4. And it gives us back some trues and falses. Now that's useful as a first step. It gives you something which, if you look at with your human eyes, you can see that there are trues and falses, and so you could kind of try and cross-check, and you could say, okay, so which items are greater than 4? A is true, B is true, and E is true. Okay, so that, and that have passed my test. Okay, that's good. However, we are lazy because we are programmers. The best programmers are always the laziest programmers because we make the computer do the work for us. We shouldn't have to do this manually because software is there to automate our lives. So making another cell below. I'm going to take this S greater than 4 thing, and I'm going to kind of double things up. So I said before that when you write S and you put brackets in it, you can put inside here something like A. The spaces here are just for clarification in a moment. The S's here are to, the A here is going to select row A from S. So I said if you put a single item in here, it's going to give you back that single item. However, there is a special shortcut mode that if you put inside these square brackets something that is a list of trues and falses, or more specifically a series of trues and falses, it will use that series of trues and falses as a mask. And anywhere where there is a false, it will not show the data. And anywhere where there's a true, it will show the data. So here we can paste in our S greater than 4. So S greater than 4 is inside those square brackets. And when we run that, it gives us back just the things that passed the question. Now this here is obviously a simple example. It's just asking a small question about your data, is it greater than 4? But you can ask more complicated things. You can say, if s is multiplied by 2, is it still greater than 4? And here we see that we've got extra data has come through. Now while c, i.e. 3, isn't greater than 4 itself, if you double 3 to 6, 6 is greater than 4, and so it passes the test. And so you can put relatively complex questions inside your square brackets here, and that's going to give you the ability to filter down your data and discover the things from it that you really, really want. Hopefully throughout the session today we'll be seeing more examples of this, but at this point I want you all to have a go at doing that yourself. Have a play with the putting different numbers in here, try making different series yourself, and see that you can reproduce this and make sure you understand how it works. If any of you have any questions about what this does, how it works, or what kind of extent you can take it to, please do have a chat with us in the chat there. And apart from that, I'll be jumping back in again in a minute or so. Okay, so hopefully you've all had a chance to have a little play around with querying your data like this. There are other ways of querying data in Pandas. We'll be seeing how they interact with larger forms of data in a short while, but there are also other techniques out there. I do recommend having a look through the Pandas documentation after this session. Some of it is very technical and dense, but some of it is written for relative beginners, so you should be able to get some useful information out of it as well. I'll point you towards it towards the end of the session. So the last thing I wanted to cover on series, which is going to be useful later on, is how you can do things between two series. So here I've defined two more. I've got S2 and S3. One's got largish numbers in it, and the other one's got smallish numbers in it. As before, we saw that we can do S2 minus 5. That subtracts 5 from all of the values inside S2. So 23 goes to 18, for example. But if you've got two series which are the same length, you can do S2 minus S3. And it will subtract the corresponding elements from the two of them. So it does 23 minus 7 is 16, 5 minus 6 is minus 1, and so on and so on. And again, it does this very quickly. It will, even if you've got like a million items inside here, it will be able to subtract one from the other in a fraction of a second. So you generally don't have to worry about the speed. As long as your D types are showing up correctly as int64, and as long as these are a similar size thing, this is always going to be a nice fast operation. You don't generally have to worry about that. If you do get to the point of having to worry about your data being far too big, we'll give you some information at the end of the session to come and talk to us about how you can get help after the session. So moving right down to the bottom of this, what was the title of this page? Was Introduction to Pandas. Moving right down to the bottom of that page, there is a final exercise here, which I will just go through with you. So create two series of equal length with no specified index and containing any values you like. Perform some mathematical operations on them. That's what we've just done there. Now what happens if they've got different lengths? Let's have a look. So let's make S3 shorter. So S2 we've got 5 elements in, S3's now only got 4. If you subtract one from the other, I didn't run that cell again. Classic thing that happens, if you change a cell but don't run it, then the values that are set inside it don't get updated. So you have to make sure you always run a cell after having edited it. So here we see that S2 minus S3 is done 23 minus 7, again, 16. 5 minus 6, minus 1. All the way down till it's got to 7 take away 4 is 3. Then it's trying to do 5 take away, well, there's nothing there. And it's important to be aware of the difference between 5 take away 0 and 5 take away... And at that point I just paused, because there's nothing to subtract from it. There's no definition of what you, if you do 5 take away something that just doesn't exist, what the answer should be. It's not 5, it's not infinity, it's not anything. So to handle this situation, Pandas and generally most Python and other programming languages have a type called nan, which stands for not a number. And so any situation where you do something that represents something that isn't a valid number will put a nan in its place. Now nans are viral, So if you do nan times 3, that's going to be a nan. If you do 5 minus nan, that's going to be a nan. So nans become sticky and they hang around. Another good question in there from Anna. Why are they floats now? So I was about to come on to that, but I'm glad you pointed it out. So 23 minus 7, integer. We've clarified they're integers from before. But now for sometimes it's 16.0. And for the pure mathematically inclined out there, you might think that 16 and 16.0 might be technically different things, and they are in programming languages. The reason it's had to do 0.0 here and turn them into floats, and you see it's a float 64, is because the whole column of values has to be of the same data type, and there is no way to represent nan inside the integers. Integers go from minus a big number to positive a big number, and there's no bits of information left over to represent nan. Floats, however, do have a special little set of bits built into them which represent nan. So as soon as your column gets nans involved, your numbers are going to turn into floating point numbers. Now, some of you might not be seeing floating point numbers here because this is one of the things that's changed with the recent release of Pandas 1.0. It's now a little bit different, and you can have integers with nans because they do something a bit cleverer. So in the future, this might not be happening, but it's worth being aware of. Okay, good. So with that, we are going to move on to the next section. At the bottom of that page, there is a next button. And we are on to data frames. Now the term data frame, as far as I'm aware, was stolen from the R programming language, either from the language itself or from one of the packages, I'm not actually entirely sure. At its core, you can think of a data frame as a table of data. So a series is a one-dimensional list. It is something which just goes along in one direction. They are originally technically designed, I suppose, for use as time series. So in our examples before, we had indices which were numbers, automatically generated 0, 1, 2, 3, or A, B, C, D. But you can have an index being a complicated value, like a timestamp. So a series might be used, for example, to store all of the samples from an experiment. Maybe that's all of the temperatures throughout a day, or all of the atmospheric concentrations of CO2 throughout a year. That's a one-dimensional set where there is one piece of information, but repeated, and each piece of information, each row, has a label saying when it was collected. So that's what a series is. A data frame is a table of data. And so where you can think of a series as being a column, a data frame is a set of columns all connected together. At its core, a data frame is made up of a bunch of series put next to each other, making up a table. That's what they do. And as soon as you start operating on data frames, start asking questions from them, you are going to start getting back series. And this is why we've started with the simpler series type, because very quickly data frames devolve into a series, and that's how you start operating upon them. So we'll start by importing this, and I'm actually going to start a new notebook. I'm going to save the old one, but I'll leave it open. I'm going to start a new notebook, and I'm going to call this one Data Frames. And we start by from pandas import data frame. Now there's a question in the chat about how often do you have to do this import. Generally you do it once at the very top of your notebook, and then it persists for the rest of that session. This next bit I am going to copy and paste because there's no way you want to sit here and watch me type out all of this. That would be very boring for everyone involved, and I would absolutely definitely make a mistake. So this is just a plain old Python dictionary. Each key is a string, and each value is a list of items. Each of these three lists are the same length. The way this is going to work is each key is going to be used as the label for a column, and each value is going to be used for the values in that column. So we go ahead and run that. Now, at the moment, that's just a plain old dictionary. If you want to turn it into a data frame, we should go ahead and use the, if I could spell, data frame class, which we've just imported at the top, and we pass it our data in the same way we passed our series, our list, to the series. There's a convention to name your data frame df, and that's a bad idea because it doesn't describe it, so I'm going to rename this to census. I think that's how you spell census. Then in the cell below, I am going to print it out, census. You're going to see me lots of typos in this session. There we go. Just going to make sure I've got my chat window open. Good. So you can see here, we've got a table. We hover over it and we see all the lines showing up nicely. So I didn't mean to scroll there. We've got 3 columns because we had 3 items inside our dictionary: city, year, and pop. City, year, and pop. In the city column, we had Paris, 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 and then 4 Londons and then 4 Romes. We see the same thing here. So it's maintaining the order of the data. At this point, we don't care about our dictionary anymore, so I'm actually just going to scroll down to the bit that matters. We've taken our data, we've printed it out. You can think of each of these columns as being a series, and you'll see there are 3 columns, so there are effectively 3 series being involved here. If you remember before, every series had its own index. The way that a data frame works is it combines all the indices from the parts together and gives one overall index all the way down the left-hand side. And now because we haven't specified an index, it's assigned one for us, again, the integers displaying from 0. So I'm just going to give you a few seconds now just to copy and paste and run that code yourself. Make sure you can import the module, make sure you do this line here, and make sure you can get to the point where you've got a table displaying in your code. So give you a little bit of time there just to have a go at that, and then I'll jump back in. Okay, so I'm not seeing anyone shouting for help in the chat, so I'm going to assume that on the whole things are working well. And again, if I'm going too fast or too slow, please do say something. So there's a few things that we can do with these data frames. First of all, you see this data frame here already fills up most of my screen. I do have my font size set quite big, but it fills up most of my screen. In the case that you've got hundreds or thousands or millions of rows, this isn't going to be tenable. So one thing you'll often want to do is just have a little peek at the first few rows of your table, just to kind of get a sense of how it's looking. And we can do that by writing census.head, and you give a number of how many items you want from the head of the table. In this case, maybe 3, and you see it prints out the first 3 items. Similarly, you can do, tail, head and tail, beginning and end. These are quite common terms in programming languages, so you'll see these cropping up a few times. The other thing that we want to be able to do, and it's going to lead into some of the really powerful stuff we're going to be doing throughout this session, is grabbing data out of our table. So we start with our census. With our series, when we put stuff in square brackets, if you remember, it would select by row. So you might think you put census 1 and it would give us out this row here. But actually, the way that data frames work is that they select by column first. So in here, we have to write something like city. That will give us back the city column. So to reiterate that, a series selects by row, a data frame selects by column. That's half true, and I'll explain exactly how this can get more messy in the future. If you remember that we selected by row in our series, but we could also put in those questions with the trues, falses, and that worked too. And we'll see things like that carrying on being the case. But on the whole, if you just put a single item in, it's going to look for a column by that name. And if we look for something which is not there, it will give us a big scary red error, which if you scroll down says key error not there. That's it saying there's nothing by that name. So let's go back to city. This has given us back a series, exactly of the type we were dealing with before. The only extra thing it's got is now it's got a name. It says name city, and so we can remember which column it came from. We can check the type of it by wrapping the type function around it, and we see that it really is a Pandas core series object. So that means we know exactly how to deal with it. So let's start through that again. Census, square brackets, city. So we could say something like, I want to select all of the rows where the city is Paris, because those are the census informations that I want to do my subset of my analysis on. Because this is a series, we remember before that Boolean operations on series give us back a list of Booleans. We expect to get the same thing. And we do indeed get a list of trues and falses, where the trues are the rows where it was Paris and the falses are elsewhere. Now, as before, we can take anything that's a list of trues and falses with associated indices, an object like this, and like before we passed it into S, in this case we can pass it into census. And inside those square brackets, I'm going to copy and paste this thing here. And the reason I put those spaces around it is because the proliferation of square brackets can get confusing. So these outside square brackets are asking a question of census, and so they're going to give us a subset of census. These inside square brackets here are selecting the column on which we're asking this question. So this here is a list of trues and falses. It's going to mask and select down just the rows from the census table, the thing up above, which match this question. And so when we run this, we get back just these items here, which match Paris. Have a little go at that yourself, make sure that's working, and then I'll carry on to the next bit. So we selected here census, and to select a column out of it, we just put something in the square brackets. It's quite common that you actually want to select by the row index. And so to do that, you do .loc, which stands for location. Not the best name I know, but it does work. And if you put the number 3 in there, it's going to give us back the row that matches the index 3. So it gives us back Paris 2010 2.244. So this is a way that you can get rows of data out of your Pandas DataFrames. But the reason it's made a little bit more difficult than getting the column out is due to the way that the stuff's laid out in memory, effectively. It has to ask more and more difficult questions and do more work in order to extract a row than it does to extract the column. You can think columns are pre-prepared, but rows it has to go and find the data and reassemble it into a series. So getting rows out is possible. It is slightly slower. So it wasn't slow, but it was slightly slower, and that's why they make it a little bit more difficult to get access to. We can also add new columns. So here we have census, and we have a look at that table. It looks like this. So we can add a new column to it. For example, a column called continental. Again, spelling catching me out. And we can assign a value to it. So this is going to make a new column with that name. And so the value we assign to it needs to be a list of numbers to fill the column with. The easiest way to get a list of values to fill the column with is to generate one from one of the other columns. So for example, let's put some spaces there to make it clear what's going on. df city is not equal to London. So this is going to ask of the city column where it is not equal to London. That's going to give us back a list of trues and falses. We're going to take that list of trues and falses and make a new column out of it. It's not called df, is it? It's called census. Thank you. There we go. So now we look underneath and we print the census table, and there's now a new column here which has got our information in it. And we could then use this in queries as we go forwards. To delete that, we can use the del keyword, which is valid Python in many contexts, but is very uncommonly used. And you can delete a column, such that when we then look at it again, census, it is now gone. So you can add and delete columns at will. Have a go at the exercise at the bottom of the DataFrames chapter. So do this same thing that I've just been doing there. Have a go at selecting some data out of it, and then see if you can find all of the cities which have a population smaller than 2.6 million. At this point, I should point out that I've done a very, very bad scientist thing, and I've got a column here with numbers in, and I never told you what units they are in. I assume you can work out they're not individuals because you can't have 2.148 of a person. They are in fact in millions. So when it says smaller than 2.6 million, it's asking for a value that's smaller than 2.6. Have a go at those for a few minutes, and then I'll update everyone before we jump onto the break. So I want to go through the answer to one of the exercises there. So the bottom of this page, this middle exercise here, select the data for the year 2001, We'll see how to do that first. Then the question, which city had the smallest population that year? Now, to answer the second part of the question, does require a function that you haven't been taught yet. So I'm going to teach it to you now and show how we can do this and build it up stage by stage. As Crystal was saying in the chat, the best way to solve these things is to start small, do one small bit at a time, and slowly build up your line. Because even a line of code like this one can be a little bit hard to parse when you're first looking at it. So either build it up part by part, or give temporary variable names to each step and then use those variable names in later steps. But let's get to the exercise. We have, let's make sure I've got my thing here. So we have df year. That is, oh no, it's census, isn't it? Teach me for reading off my notes. Census year. These are all the years. The first thing we want to do is grab all the stuff for the year 2001. We can do that by selecting where the year is equal to 2001. Trues and falses. So let's pass that back into the census dictionary, census data frame. So this is going to give us back all the bits from census where the census year column is equal to 2001. There we go. We've reduced our data down. Now the question in the exercise was which city had the smallest population that year? So if you just looked at this and said Paris by reading the numbers, that's a successful way to answer the question. I can't fault you for doing it that way. But bear in mind, you could be dealing with much larger tables, or it might be running from data which is streaming in live, and so you can't look at it manually. So let's look at how we would do this using Pandas to do it for us. The first thing to look at is we've got this information here. The next question we want to ask is what data in the population column is the smallest? Well, let's start off by getting the population column. That's given us just the data out of that column with row 0, 4 and 8. Notice it hasn't renumbered the indices, it's maintained their original numbers from the original table, 0, 4 and 8. And what we can do is take this and assign it to a new variable because I don't want this line to get too complicated. So I'm going to call this pop. And we've got a variable called pop, which is the same thing, but it means we've always able to refer back to this set of data. If we look at pop, let's get rid of that highlighting, we could do min. Calling min on a series gives us back the smallest value in there, so 2.148. We could use that number and then refer back to the table and find the column, so we'd find the row which has that population value inside it. But that's a manual process and we want to use the computer to do our job for us. So there's a function built into it, and this is the one I didn't tell you about, called idxmin, which stands for index min, i.e. give me the index of the row which has the minimum in it. In our case, the minimum is this, and so the row, the index of the row is 0. So this should return us 0. If we change this to index max, we see we should get 4. And we do, but we don't want max, we want min. So given that, we now want to use the fact that we know which row had the smallest population in the year 2001 by going to our census table, grabbing the city column, because we want to get the city out at the end of it all. Actually, no, let's do it the other way around. Let's do this. No, let's do city column first. City, which gives us back the city column. And then that's a series, so we can ask a question of the series by chaining together these square brackets and put inside there this question we asked. This is 0, so it's going to get the 0th row from the column here. We run that and it prints out Paris. So that is how we answer this question. Remembering that pop is actually this thing here. So if we wanted to, we could copy that. We could use our thing here, replace pop with it, get rid of these spaces and run that. And we should get the same answer. We do. And when you look at that line of code there, you realize why I split this onto multiple lines with multiple variable names, because while this answered the question, it's a very dense and difficult way of understanding it. We've got just over an hour left today, so we've got two main topics I want to get through still. The first of which I'll jump into now, and we want to make sure we get round to making plots before the end of the session, because For a lot of you, that's going to be the reason that you came. So, I've made a new notebook here. Still got my old ones open, so we can refer back to them. But we're going to start off, let me just get my notes up. We're going to start off going through how we go about reading a file. So switching back to the notes. Pandas has built into it lots and lots of ways of reading files from either from your local hard disk or even downloading them directly from the internet. It's got a variety of tools for different file formats. One of the most common you're going to see is comma-separated values, CSV files. But I would not be surprised if many of you are also dealing with Excel spreadsheets. In some domains, you'll also come across file types such as HTF5 or even SQL or SQL databases too. Beyond that, there are a number of other file formats which Pandas supports, but those in my experience are by far the most common. To show how Pandas gives us the ability to read in these different data formats and to deal with the inevitable messiness that comes with them, we're going to go through an example now. In my experience, files that you're reading in are never quite in the format you want them to be. You might wish that they were perfectly laid out, neat, everything there, nothing missing. But realistically, the real world gets in the way and we have data which is messy. Either it's poorly presented, poorly laid out, or just has stuff missing from it. So if you've already come onto this page, we had to update the page in the break because something had changed and it wasn't working anymore. So make sure you refresh this page before you carry on copying the examples. So I'll refresh that now to make sure mine's refreshed. There we go, refreshed. So here is a CSV file example. It's available at this link here. So this here is the contents of that file. It's got some text at the top which describes what's going into the file and sort of an explanation about what's inside it. Then it's got the actual table of data itself. You'll notice it's using semicolons instead of commas to delineate the different columns in the table. It says up here a -1 signifies a missing value. So we've got some -1s, which mean there's no census data for that year. There's also some places where we've just got two semicolons next to each other, and that's meaning that in this gap here, there's again missing data. So there's lots of missing data. It's in a strange format. It's got some stuff at the top we're going to have to deal with. And I'm going to go through now how we can deal with this stuff and how we can get Pandas to read it in a nice way. So we start off by importing Pandas. There is a convention that when you import Pandas, you import it as PD. It doesn't matter. You could do all this just with import Pandas. But when you come to finding examples online, you'll see people using PD dot something quite a lot, so it's worth getting used to seeing that. Make sure that's imported. So the function that we're going to be using today is something called pd.read_CSV. There's a whole bunch of read_somethings. In fact, let's just have a quick look at them. This is just loading up. Read CSV, FWF, JSON, HTML, etc., etc. I won't read all of them out, but there's a lot, as you can see. The nice thing that Jupyter Notebooks give us is that if we've got a function and we don't know how to use it, we can just use a question mark and then run that cell, and it's going to print out the documentation for it. And you see here the documentation for read CSV is long. This is an example of what might be considered a bad function because it's got far too many arguments to it. But it's one of those situations where they've tried to find the balance between functionality and usability. On the whole, I think they found it correctly, but there are a lot of arguments. These are just the arguments and their default values. Scroll down further, and it has a description of each and every argument in there. So we're going to be referring back to this along the way so that we can see what we need to do. To that end, I'm actually going to switch back to the notes here, and there is a link after import pandas pd to the manual. So I'm going to click on that link, and this is that same thing but on the web page because it's going to be easier for us to search through it on the web page. So the first thing we do is pass in the file that we want to read. Now I've prepared a file for you at a link which I'm going to copy and paste there. Again, this is in the notes. This is just defining a string. We are going to pass that string to the read CSV function. And there we have it. It has downloaded the file, opened it as a CSV file, and has attempted to interpret everything that's inside it. As you can see, it's done a job, but it hasn't done a brilliant job. It is naively assuming that everything in there is a CSV file, and it's asking for us to explain anything that's outside of that loose convention. So the first thing we'll see is it's included the comments at the top, all that stuff that was explaining what was inside the file. I'm going to reorganize this. You can do this in Python. You can have a function call with arguments, one on each line. And I'm going to have to use another argument to this function to tell it that it should skip some of the rows. So I'm going to go to the documentation, and I'm going to Control F and search for skip. Now, skip initial space. Let's do match, highlight all. Skip rows. That sounds like the one we want. So let's look for skip rows. Skip rows, and go down the page. And here is the documentation for that argument. It says the line numbers to skip. That's what we want. We want to tell it how many line numbers we want to skip. So let's go back to here and pass in skip rows equals, and I think it is 5 we want to skip because there were three comment lines, then 2 blank lines. If we run that, there we go. Those comments at the top have disappeared, and already it's looking a little bit better. We've just got the data left over. The next thing is that this CSV, again in inverted commas, isn't using commas to separate the values. It's using semicolons because I was trying to be deliberately obtuse when I designed this file so that we could learn together. So again, we go back to the documentation and go to the top, and we want to find out how to tell it which thing it should use to separate the columns. So let's just start looking for sep. There we go, sep. There's an argument called sep, which if we go down to, delimiter to use. Now, delimiter means the thing you use to separate stuff. If it's none, it tries to guess what it is, and it assumes that it's a comma. And you see here the default is the comma. So let's do sep equals, and then it's a string. It's a semicolon we want to use as. And so now we run this, and there we go. We're basically there. So we've had to tell it what file, what to skip, and how to separate it, and it's pretty much done the right job. You'll see in those places where we had those consecutive semicolons, we've now got nans showing up because there is missing data. They are not numbers. They're not 0. Population of 0 is a valid population. These are not values. However, you will see that there are these -1s in there. And if you remember from the documentation that we had at the top of the file, it said a -1 signifies a missing value. You'll notice partly that it's changed it into -1.000. Again, because of the whole nan thing, it's converting them all into the same data format. But we want to tell it that -1 is not a valid number. It is in fact actually signifying missing data. So there we can write, well, let's have a look through. Let's have a little browse at the top. This is generally the way that I work when I'm using a library. I sit here and I stare at this and see if I can work out what's going on. So let's try searching for nan. Nan. NA they're using here. Okay, so NA filter true NA values. Let's have a look at NA values and scroll down the page. Additional strings to recognize as nan. Okay, so we give it a list of strings and it's going to use them as nan values. NA values equals -1. And now we should see these -1s turn into nans. Let's watch that happen. 3, 2, 1, bam. There we go. It's now representing all the missing data as nans. The last thing we might want to do is that here we have 3 columns which contain data. Some of them missing, some of them aren't. But we have a column here which is unique. And in a census, you would normally use the year as the primary index by which to say which year you care about. You say the first thing you talk about is which year you're talking in. We haven't told it what index to apply to our data frame, and so it's generated the 0, 1, 2, 3 defaults. However, we can tell it that it should use this column as the index, and so it will take these numbers and use them as the index and have it not as a column of its own. And we do that by passing in the index col argument. We switch to the documentation, index col, columns to use as the row labels. That's exactly what we want to do. Equals year. When we run that, we see the year has become bolded, it's now down there, and we've got our data frame all working together. And because we've done that, it means we can do something like census equals this. Census like we did before, get the city column. Oh, hang on, no, it's not called city anymore, is it? It's called, it's a different layout. Let's get the information for London. And you see here, it's giving us a series with the columns being the years, which means we can say something like 2001, and it gives us back the population for London in the year 2001. Lets us very easily navigate down our data. So for the exercise here, go to the bottom of the reading from file chapter, and there is a link to, and I'll just go there myself. There's a link to this DAT file. So do the same thing that I just did, but doing it over this DAT file instead. And if we look at that file, okay, it's not going to let us look inside it. That's annoying. Actually, we can have a look at where it came from on the Met Office website. Loading, loading, loading. Loading, loading, loading. That's not going to load. So in the meantime, just take that URL there and paste it into the same read CSV thing we did above, and try doing that same thing. Try just fiddling with the data, try adding in skip rows, changing the separators, things like that, and see if it starts to look how you want it to. And if you get stuck, have a look at the answer, and otherwise I'll go through you all with it in a little bit once you've had a chance to play yourself. Okay, so got a question in chat from Jesse. Let me just get that loaded up. So you're writing this string here and you run it and it's saying invalid syntax. And the reason that's happening is because on Windows, they use the / character to represent folder separators. However, in almost every programming language, / is used for control characters. So for example, \n is a new line. And so it's reading your string here and seeing this as \U, which I think is how you write Unicode characters, and \W is something else, etc. So one thing you could do is replace all your slashes with /, because they work fine on Windows. Otherwise, as Chris says, do an R at the beginning of it, which makes a raw string, and then that will work successfully. Okay, so I'm just going to go through the first part of the exercise there. So the first part was just to open the file and get it all read in correctly. So leaving that other stuff on the screen there, I'm just going to paste that in, and I'm going to comment out the magic bits so we can kind of build it up bit by bit. Feel free while I'm doing this to just carry on going through the exercise yourself. If you've done this already, you don't have to listen to me. Feel free to carry on through the other bullet points, looking at negative temperatures, etc. But for those who are interested, I'll just go through this on the screen. So we read the CSV in from that file. I've commented these out so those aren't being applied. And we look at it and it looks all wrong. All the files are in the wrong place. It's got all this extra information at the top, which we want to skip in the same way we did with everything else. So when we run it again with the skipped header, suddenly we're getting data that looks correct. Again, it's assuming that it's comma separated values, but our table, as we saw was not comma separated. They're separated by spaces. So we want to tell it that instead of using commas, it should use white space to separate the columns. And if we now run this, we see that it works. I'll point out one thing about this data because we are going to be using it in the next section, and in fact for the other exercises. The year column here isn't the year in which the data was measured. It is the average temperature for that year, in the same way that the October column is the average temperature in October. The final thing we have to look at, and if we look at the end of the table, this will be clearer with tail. In 2019, there's a bunch of 999s at the end. And that's because I downloaded this file and put it on the website in October 2019, about 6 months ago. And so there's obviously no temperature data for the future from their perspective. Now, it tells us in the format on the Met Office website that -99.9 and -99.99 both represent missing data, in the same one that our -1 did before. And so we can use the NA values to set them to nans. So when we run this, we see the nans showing up at the bottom. That last bit there is very easy to miss. It's also very easy to miss the difference between with 1 9 in the decimal place and with 2 9s in the decimal place. Yes, there's a question there about whether delim whitespace is the same as /s+. It's a very good question. And in fact, I can answer it by going to the documentation and looking for delim whitespace, and it says right here, equivalent to setting sep is equal to /s plus. Now this, for those who haven't come across it, is called a regular expression. These are very powerful ways of matching patterns, which we don't cover in this course. If you are experienced with them, you'll recognise what this means. In essence, it means a bunch of whitespace. But to avoid people needing to know regular expressions, they've added in the delim whitespace argument to make that easier for people. Bo asks, how can I set all negative values as nan? So I don't believe there's a built-in way to do that using NA values, unless you only have a subset, a strict set of negative values you're dealing with. The way that I would deal with that is to read the data in and then do a second pass where I loop over that column or apply a function to that column which replaces any negative numbers with nans. So there's a function called apply, which applies a function you give it to every row, every item in a series, and you could do a if statement inside that function which would check things out, which would compare it to 0 and then return none if it was less than 0. So I would do it as a second step after the reading in. I don't think read CSV has got built-in functionality. You could argue that read CSV has got enough arguments already without adding in any more. Yeah, exactly, as Christopher's done there. So I'll see if I can demonstrate that. So let's get rid of the NA values one here, and it just has these 999s. And if we, on the row below, do df, where df is less than 0, is equal to none. So that's going to find all the places where the df is less than 0, and it's going to set them to be none. So when we run that, and then look at df.tail, let's see if this worked. Christopher's reputation's on the line. It did indeed work. So I would do that as a second step. Okay, so I assume that people have managed to read in that data file using the example in the notes, and I should point out again, I say again, I don't know if I have pointed it out yet. On every exercise, there is almost always, I think always, an answer link. So if you click on that, it will take you to the answer, where this is the lines of code that I just copied and pasted from. So if there's ever an exercise you're stuck on, you can always find out the answer and get a little bit of help. But do try and have a go yourself with these things first. So I'm going to have a look at these other two exercises here. How many years had a negative average temperature in January, and what was the average temperature in June over the years in the data set? So there's a few kind of slightly more complex questions we might want to ask there, but the sort of thing that if you're doing meteorological data are the kind of questions you might want to be asking. So the first thing there was how many years had a negative temperature in January? So we've got our DF, which again shouldn't be called DF because that's a bad name. It should be called temperatures, but let's just carry on for now. Let's start by looking at January because that's the month that we care about. That's the column. If we ask a numerical mathematical question of that or a logical question of that, it's going to give us back another series. So we can say where Jan is less than 0, that's going to give us all of our negative values. You see it's done falses. It's done a ... in the middle because that jumps from 1663 to 2015. There's several centuries of weather in the middle. Some of them are going to have an average January of less than 0, but for some reason the first 5 and the last 5 don't. We take these trues and falses and we pass it back into DF. And that's filtered down our data, so we see that all of these first column here values should all be negative. So 1684, 1695, 1709, etc. all have negative values. If we want to find out how many there are in here, the easiest way to do it is to call the len function on the list. No, my computer's having troubles. There we go. So I've just passed this data frame into len. No, I need to... That gives a different answer in my notes. Because I've got an extra pair of square brackets there that I put in accidentally. There we go. So df jan is less than 0. df of that, there we go, is 20. So there are 20 rows which have an average January temperature of less than 0. I think there is also another way of doing it, which I'm going to try and work out live with you all in front of me, which is always a risk when you're programming. There's a bunch of functions you can call on data frames. So the result of this whole thing here is that it's a data frame. So there is, for example, I think it's summary. Nope, not summary. Count. This is where I should look at the documentation, but I'm being the wrong kind of lazy. So there we go, called count on a data frame. It tells you for each column how many items are inside it. I think by default it doesn't count nans, but it will count anything that's not a nan. So here's another way we could have done it. We could have said data frame of January dot count. Or if we wanted to, we could have taken from our data frame, we could have grabbed just the January values, and then we could have called dot count on that, which would have given us 20 as well. There is, as they say, more than one way to skin a cat. I don't like skinning cats at all, but if you're going to, you can do it with code. The other question that was in the notes, which I'll just move down for, was what was the average temperature in June over all of the years in the data set? So again, average temperature in June, thing to start with is looking at the June column. Here's a bunch of data. If you want to find the average of a series, because remember when you get a column out of a data frame, it gives you a series, there is a function called mean, which you just call directly on the series, and it returns you the single value of the mean, 14. So over the last several decades in some measurement location in the UK, which is where this temperature data was collected, the average June temperature, or the average of the averages, I should say, is 14 point something degrees. If we look at the Jan temperature, we see the average Jan temperature is 3. This tells us we are probably in the northern hemisphere. Yes, question there about why the first example I did up here didn't work. I think it's because I accidentally missed off df there when I was typing and overwrote it. So it was giving us the length of this list, which is a list of length 1, and so it was just giving us 20. We could actually, I think, have not do that at all. And that gives us, that gives us all of the trues and falses, which is 361. So we want to be able to select just the data from it that is has the true value, which is those that are matching this predicate, 20. So there's a question there, how do you set the index column if it doesn't have a name? That's a good question. So the data we were dealing with here actually had its first column, the one that had the dates inside it, didn't have a name. I'll just see if I can... I don't think I have the original file anymore. Let's have a look. This is a peek behind the curtain at the material. One thing I didn't point out earlier is that the website you're reading for the notes, everything on there was written using Jupyter Notebooks. So these are actually notebook files which get compiled into HTML and presented to you. But let's have a look at the file that we're dealing with. This one here. So you'll see here, this first column here with the numbers in doesn't have a column title. And so Pandas has taken a guess and has decided that this must therefore be used as the index. That makes sense. And so it's decided to use it as the index. If you have a column in there which doesn't have a label, then what I would normally do is explicitly tell it what the label should be. So instead of it having read the file for the labels, I would say, give these the names, year of measurement, January, February, March, etc., 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 year or average. Then once that's done, I would use the labeled that I've now given it a label as a thing I pass to the setIndex function to say use this column as the index. So I do it again in kind of 2 stages. So Jesse, your question about you've got a list there, can you use a mask expression to find values? I don't think so. I'm often wrong. So let's have a look at the documentation. Actually, do I have it open already? No, I don't. And let's have a look at NA values. I did skip over it earlier. So NA values takes a scalar, like just a number, a string, a list like, or a dictionary, and it is optional. By default, it's this. So there's no option here for the type of this to be a function. So there's no ability here to pass in something which is either a function or something which maps something. So built in, there's no ability to do that. So I would suggest using the feature that Christopher found for us earlier, where we did, commented that out, and then we did, no, sorry, we did df df less than 0 equals none. But instead of doing df less than 0, you could do some other predicate inside there. So back to the notes here. Been through these exercises. We've opened and read this separate file. Make sure you keep that bit of code around because we're going to be using it in the next section. We have done some questions on the data. We've asked about negative annual temperatures and the average temperature in certain months. And this is the useful kind of things you do. So obviously in this course, we can't get fully into depth about doing every single type of analysis. We have another course which will be running a few times after Easter, so in the next month or two, called Applied Data Analysis in Python. And there we actually learn some analytical techniques for studying more complicated things about your data. But a lot of the time you just want to do relatively simple filtering, and that's what we're doing in these sections here. The other thing that you often want to do with your data is not to look at it in a form that looks like this. I mean, it's nice to be able to look at your data in a table, but really you want to be able to see a better visual way of representing it. So for example, here we see we've got 11s and we've got 13s and we've got other things happening. It's hard to see trends in a table because you can't see anything really happening. You can see a bit of a trend. So if you look at the July temperatures, they slightly go up. They're 13s up to 16s. You know, there's maybe a trend there, but it's hard to see in a picture. So we are going to move on to the next section, which is plotting. Got just over half an hour left, which is perfectly on time. Moving on to the next section, which is the matplotlib URL. Plotting data with matplotlib. Matplotlib is the de facto default plotting library for Python. If people could just post in the chat whether they've used matplotlib before or not, that would be an interesting kind of sample to get a sense of where people are. Yeah, so there's a lot more people saying yes, they've used it. I mean, I wouldn't expect everyone to have by any stretch, but it's hard to avoid using matplotlib if you've ever done anything sciencey in Python. Now, what I'm going to show you in this first section here, while it uses matplotlib, you don't actually need to know any matplotlib at all. It's a very shortcutty way of doing things because Pandas has built into it an interface to matplotlib which does all of this stuff for you. So let's have a go at doing some of this stuff. So I'm going to leave my df here, which is our weather data. The simplest way to plot something is to take something like a data frame and do a dot afterwards, type 4 letters, 2 brackets, and then run the cell. And at its core, that's everything you have to do. One of the things I really love about Pandas is they've optimized it for the most common use cases. It's very common that you want to just draw all of your data and just have a look at it. And looking at this plot here, can any of you see anything wrong with it? Post in the chat if you can see what's funny about this plot. Yeah, exactly, David. The y-axis is going down to -100, yet if we look at our table, we see that all of our numbers are... Oh, hang on. Looks like I made a mistake. When I was playing around and showing you the examples, I accidentally forgot to change it back so that these -99s weren't in there. And this really illustrates one of the brilliant reasons to use plotting. It's not just for having something to put inside your paper you can publish at the end of the day. It's so you have something which can visualize the shape of your data very quickly and easily. So looking through this table, we might have seen these -99s because they're at the end, but if they happen to be in the elided section in the middle, there's no way we would ever have noticed them without doing a plot. So doing a plot immediately draws on the screen. We see the green down here behind the legend. You can just about see the line going down all the way to -99.9. So what we want to do is go back to our reading function, which is further up the page. Where is it? Here it is. Make sure we've uncommented out this bit here because I was doing a demonstration. Run that, and then have another look at df. We see that df is now nan. It's the Batman. And when we plot it now, we see our data, while not pretty, is now at least laid out with the correct values. So the next thing you would usually want to do when you're plotting something is not plot all of your columns all in one big plot. You'd want to kind of pull out some kind of particular piece of information. And so instead of doing df.plot, we can instead do df year. Oh, sorry, I forgot the quotes. So df year, that is our series. And if you do plot on a series, this one here was plotting a data frame. This one here will plot a series. We get just that set of data. We get a plot of that time series. And this is where you see the very sad fact right in front of your eyes from publicly accessible information that definitely, on average, over the last 400 years, the temperature of this part of the UK at least has been increasing. There's a certain trend of, I don't know, looks like 1 or 2 degrees, which is fairly significant when it comes to the mass of air in the atmosphere. So this, I think, is a really nice way of seeing actually global warming happening right in front of your eyes. Now, a plot by itself like that is nice. We can see our data and it's good for exploring things. But you usually want to actually do something to your data. You want to be able to label it and give some information to your reader. And so the way we do that is we say, we take the result of this df year plot thing, which as it happens is the thing that's being printed out here. It's a matplotlib thing. And let's give it a name so we can refer to it later. So year plot, run that again. Same thing happens, but now it's been stored inside this variable. And because we've stored it in that variable, we can do things to it. We can say year plot dot set y label is temperature. And then we run that, we'll get a y label appear on the left hand side. Oh, I can't spell, thank you. Year plot, there we go. Now that's all showing up how we want it to. And temperature is showing up on the left hand side. Now in the notes you might notice I've got some weird stuff going on where after temperature I've written $$ circumflex slash circ C and written an R at the beginning. And this bit in here, if any of you have used LaTeX or tech before, it's a way of representing sort of mathematical symbols. This means superscript, draw a circle, so that's going to do a small superscript circle, and the letter C. The R here is needed for that same reason I said earlier, so the backslash isn't interpreted by Python. So when we run this, we get, oh, the brackets are in the wrong place. There we go. We get degrees C, so you should always have your units on there. So have a go at that yourself. Reading the data, plotting the thing. The exercises are further down the page, just above halfway, about a third of the way down. Reproduce that plot. Try tweaking the labels. Try putting the X label on. See if you can guess what the function is to set the X label. Try plotting some different months, and then we'll move on to the next little bit. So David, as to your question about what kind of object R is, everyone else can just carry on for the minute. You don't need to listen to this. I'll demonstrate. In summary, it is the same thing. So if we look at type, no, if I could spell, I would. Type of hello, it is a string. If I look at the type of R hello, it is also a string. So the way that Python uses this R in front of it is it kind of uses it to pre-process what's literally written here before it turns it into a string. Normally Python reads a quote and it happily plods along until it sees another quote, and it does stuff to things in between like new lines. What the R here does is it changes the way that it reads through this string before making a string out of it. And what the R really means is don't do anything until you see another closing quote. Adam, to your question about square brackets and round brackets, as Christopher says, exactly right, square brackets are used for indexing and round brackets are used to call functions. When it comes to things like pandas, it's a little bit more complex than that. It's completely true that that's what it does, but I tend to think of it more about square brackets are used to ask queries of the data, because you can do more than just ask for a single index. You can pass in, for example, that series of trues and falses. So because you can put more complex things in there, I think of it more as a query syntax, where lists and dictionaries have got a very simple syntax, but series and data frames have got a more complicated query syntax. But as per the language, square brackets means index operation. And the next little section is other kinds of plots. So you might have noticed we never specified what kind of plot we wanted, Pandas just defaults to, if it's dot plot and you're doing it over a series, or a data frame which is just a bunch of series, to do a time series plot effectively. It treats it like that. Now, different kinds of plots actually need different kinds of data. And this is something that I think when you're taught about bar charts and histograms and stuff at school, it isn't always quite made explicit. But I see a lot of people making mistakes by just thinking, I've got some data and I want to represent it in this way. And maybe the two of them don't actually make sense together. For example, you shouldn't just, or you could, but maybe it wouldn't make sense, just take all your data here and plot it as a bar chart. Because arguably it's continuous data. Maybe it's continuous, maybe it's not. That's really where it starts to get a bit blurry. But for example, if we wanted to do a chart of the temperature in each decade kind of could be thought of as a independent singular value, and so we want to plot a bar chart of the temperature in each decade going across the sheet. So let's have a little look at how we can do bar charts. So at its most simple, I will do the thing I just said I wasn't going to, and show you that you can do dot plot, and then before doing the brackets there, you can write bar dot plot dot bar and then call that as a function. It's a bit of a weird syntax for people who are used to Python, but there is a way to make this work. You run that, and it does a very, very, very dense bar chart, where everything's smashed together and you can't really see very well what's going on. Now, that's not a very useful thing to do. Really, we want to look at a sort of a simplified view of this. Here we've got 300 or 400 pieces of data. Bar charts don't work well with that many pieces of data, so we want to simplify this down. So let's delete that cell and start again. So I'm going to introduce, while I'm technically introducing bar charts, I'm going to introduce a few other bits of syntax in here, which I think are useful things to know about. So first of all, we've got our data frame. If we want to get out just the years from this data frame, the years here are in the index column. They're not a column by itself, so we can't just do square brackets index because there's not a column called index. Instead, there's a shortcut which gives us the index, which is just dot index. That gives us back effectively a list of all of the index values. What we want to do to turn this column here and group these by decade is to have our table here, and the way we're going to do it is we're going to make a new column on the right hand side which has inside it the decade that each row is in. This first one will say 1650, 1660, 1660, 1660, and so on, up to 2010, 2010, 2010, all the way to 2019, being also 2010. And so to do that, we're going to do a little bit of string manipulation, and so I'm going to sort of play along with this, and if people have any questions along the way, ask in the chat, and I'll try and pay attention to both windows at once, but otherwise I'm sure my helpers will keep up. So we're going to make a new series which contains this column here, but turned into a string. So df.index, and we're going to turn that into a series. We're turning it into a series so that we can add it as a new column. Now the index of that new series has to match the one we're going to insert it into, so it has to use this same index here. So this is very repetitive, but df.index. And if we look at that, I forgot to import pandas on the screen. From pandas import series. Here we have index column, values column. They are the same as each other, and the d type is integer. However, we want to have these as strings because we're going to be doing string-like things to them in a moment. So we apply to the data in that column the string function. Looks the same, but now the d type has changed to object. And this we are going to call years because these are the years that we're dealing with. We're going to take that and we are going to apply another function to it. And the way we're going to apply this function is something you might not have come across, and that is a lambda function, which is a way of very concisely applying a bit of information to something. So this x here is going to represent each year, each row from our series. And so we're going to take each row, and that is going to be a string, which is 4 characters long, like 1659, for example, or 2019. And we are going to take the first 3 characters from it, and then add the string 0. So we're cutting off the units number from the year and replacing it with a 0. And if we look at that, we end up with 1650, 1660, 1660, so on, 2010, 2010, 2010, 2010. So this is now our data which represents the decade that we're in. We can then go back to our data frame. And assign that series we've just created with the decade strings to the decade column. So it's going to make a new column called decade. And so now when we look at df.head, we see we have a new column decade which has 1650, 1660, 1660, and so on and so on. So in order to plot our data by decade, we first had to make a column which represents a sort of a consistent piece of information for each row that we want to group together. Because the next thing we want to do to our data, a thing you can do in Pandas, which we haven't come through yet, but I'm going to introduce now, is grouping. So if you have a table of data, you can group together rows based on certain conditions. In the example earlier, we had that continental column we created based on whether the city was or was not London. So we might, for example, want to group our table we had earlier by is this continental or is it not? Then we could look for getting summary statistics for one group, summary statistics for the other, and then we can compare the two against each other. In our case here, we want to find summary statistics by grouping together based on the decade. We want to have we're going to make a new table which has one row per decade. And the row per decade is going to be made up by averaging the stuff that are in the rows that are inside said decade. Let me just switch back here. So to group things in Pandas, we do df. Remember, df is this table here. Dot group by decade. If you just give a column name, it will group by all the values that are the same in this column here. So it will make one group which contains this one row here, 1650. It will make another group which contains all of the ones that are 1660. Another row which contains all the 1670s, 1680s, 1690s, and so on. So it'll end up with one group per decade. Then we tell it what we want to do to each group. If we just look at what we get here, you see it gives us back not a table which has the groupings in, but some kind of intermediate object. And that's done for performance reasons. But we can tell it, now what we want to do to each of those groups, we want to find the mean of each group. And when we run that, we get back this. So you see here, it's made a new data frame. This is not the same data frame as before. The index is now based on the thing that we grouped by. So the decade is now the index, because we told it to group by decade, and so it's taken that to mean decade is the important thing. So use that to index our data. It's then made a row for each decade where the values in that row, for example, this 2.60 here, is made up by averaging all of the rows from the previous table, which are in the 1660 decade. So 0, 5, 5, 1, and then some more that are hidden down here. So that gives us 2.6. So this has given us a table which is now actually small enough to fit on the page. These are all the decades between the start and the finish. I know scrolling's difficult when it's like this. So let's change this to dot head, just the first few rows, or dot tail, the last few rows. Good, Christopher's doing a brilliant job keeping up with me in the chat. So the very last thing we want to do is assign this to give it a variable name. Let's call this by decade. I can never spell decade. So this variable here is that data frame that we just saw, by decade. So if we call dot plot on by decade, we will get a line plot over the decades, just like we did before. But you see how we've reduced the noise in the data because we've averaged over the values within each decade. We don't want to plot all of them. We want to plot just the year because we want to reduce the data we're plotting still. This is where we really see that upward trend very, very clearly. Before it was slightly lost in the noise, but now you can clearly see over the last 100 years the temperature has shot up. You could say the same thing between 1880 and 1720, so maybe they were worried as well, but we know there's a global trend now, not just a local one. To make this into a bar plot, we follow plot with dot bar, and there we have it, a bar plot over the decades. So in summary, to do a bar plot, you just follow the plot with dot bar, but you do have to think about the kind of data you're doing things to. So if you want to do group by, you need something to group it by, and then you need to call the group by function. Last thing on this pandas-driven plotting chapter I wanted to cover was saving a plot to a file, and I saw that someone in the chat already got to this point and having a go and they were having issues, so I'm going to go through it on the screen up here. I'm just going to delete that file because I don't need that one anymore. There we go. So let's make a new cell. And let's see about how we go about saving this file. Now, in Matplotlib, like in many tools that are around, especially in programming land, there is often more than one way to do it. Now, a well-designed API will give you one clear and obvious way to do something, but it's not always possible to only have one way to do it. So I'm going to show you a way to do this. I'm sure that some of you, if you've done these things before, have alternative methods, but this is the way that I've used, and I think it's nice and reliable. Also, it has the advantage that it works outside of Jupyter Notebooks. So if you're doing your plots just in normal Python scripts, this is going to work well there as well. So we start with our df year dot plot. It plots it to the screen, and we've got the thing showing up. However, it's plotted to the screen and has kind of got rid of the context that was around it. So I'm going to show you now how to explicitly specify some of the things that Matplotlib and Pandas is assuming for you. So the way that Matplotlib works is it works on these axes idea. Now, an axis in Matplotlib terminology you can think of as being a plot, a single XY plot or 3D plot or something like that. Now, Matplotlib also allows you to have multiple plots all on one page. The terminology it uses for that is one page which might have multiple plots in is called a figure, and then you have multiple axes within a figure. So if you want to do multiple subplots on one page, you need to start thinking in terms of figures and axes, and that's going to make your life much simpler. So the way that you'd start by doing that is calling the, well, first of all, you'd have to import matplotlib dot, is it plotlib? Let me just check something. I always forget this. pyplot as PLT. So because we're going to be using Matplotlib functionality directly in a moment, rather than just Pandas interface to it, we have to explicitly import Matplotlib. Until now, Pandas has been doing that for us behind the scenes. We then call plt.subplots. This is going to return to us by default a figure which has inside it one subplot. If we want multiple subplots, we could put in 2 there, and we get a figure with 2 subplots, or 2 axes. By default, it just gives us 1. We give them names, it returns us 2 pieces of information. It gives us the figure and the axis object. So the figure is the page, axis is a plot that we can start to draw on. By default, this plot here is empty, there's nothing inside it. We want to plot our data into this axis, which is inside this figure. And we do that by passing the ax argument to the plot function equals ax. So if we run this again, it should look exactly the same as how it did. What happened there? Subplots, sorry, it's plural. There we go, exactly how it did before. If we change that to 2, it's going to complain because we are getting back 1 axis object, but we're asking for 2. But we can do that if you unpack the arguments. Once we've got this, we can then refer to this figure object, which knows about everything that's inside it. And so we can end the line with fig.savefig, and we give it a name. my plot.png, let's say. And it's going to save that. And you see, as I press that, my plot.png appeared over here on the left. Let's prove that happened by deleting it and running that cell again. It appears over here. We can open it up and we see this is the plot. In Markdown mode, we can code Markdown. We can then display that plot by using the Markdown syntax for showing a picture, which is my plot.png, and then it shows up in Markdown mode. This is a picture, so we can have hello, bye in front of and behind it. So that's how you save figures. And if you have your analysis pipeline from reading in your file, doing your analysis, all the way through to saving your figure, you can then run that anytime and update all the plots in your analysis in one go, which is a really, really nice way of working. So in the last few minutes, I'm not going to do any more code because the very last section in here, if you go to the bottom of the matplotlib chapter and press next, there's a section called Making It Prettier. So this section, again, I suggest you have a look through in your own time because there's quite a lot of very dense code. Do email us if you have any questions. But to summarize, with matplotlib, you can go from making a plot which looks like this, which is using the default colors, default axis labels, etc., until you get a plot, excuse the scrolling, that looks like this. So there we've changed the axes, we've changed the colors, we've added in labels and written mathematical texts, we've put in a legend, and it's able to present things in a nice way. So matplotlib gives you the ability to do that, but if I scroll up just a little bit, you see that the code can sometimes be a little bit complicated. So have a look at this section in your own time later on. I tend not to go through it in the class because it's just a lot of repetitive stuff. But do have a look at this, go through it step by step. It should explain what's happening along the way, and you can see how you can start to design your plots to be a little bit better presented. Moving on to the summary now. That's everything I wanted to talk about in the course, basically. So thank you all for coming along today, and I'll hopefully see you again in a course in the future.